As you can see by all of the stuff in front of me on my assembly table, I have got a lot of PVC parts. I decided to duct in the dust collector system with PVC. I went with the sewer pipe version instead of the Schedule 40 or Schedule 80 for a couple of reasons. One, it is significantly lighter than Schedule 40 or Schedule 80, and two, it is significantly less expensive. Now I went with 4-inch components. I looked at going with 6-inch because I can get 6-inch out of the cyclone separator all the way to the tool, and that would be ideal. When I priced it out and looked at all of the components, even doing it with as budget a piece as I could, I was going to be over $500 in material cost, closer to $600 to be honest. I could do it all in 4-inch PVC for a little over $150. And the last time I checked, almost $600 is a significantly bigger number than a little over $150. So 4-inch it is. My rationalization is that I am currently doing everything with flexible tubing today, which is notorious for introducing turbulence and friction in the airflow. So at the very least, by going with the smoothed wall interior of the PVC, I should significantly improve the airflow until I have to jump to the flexible tubing to connect the tools. And then instead of having big long runs of the flexible tubing, I'll just have little small jumpers from the PVC to the tool. My goal is to have several different drops. I'm going to come out of the cyclone, I'm going to go up across the ceiling, I'm going to come down at the table saws, I'm going to come down at the joiner planer cluster, and I'm going to have one more drop that I'm going to come down that's near the drill press, a sander I have, and a router table. So that will sort of have to be one of the few places where I move the ducting around as needed to connect the tool, but I'm okay with that because today I'm taking everything tool to tool. I debated about doing time lapses or showing the installation, but there are a ton of videos on YouTube of installing all manner of PVC dust collection systems. I'm not going to do that. I'm going to get it all installed and then I will show video of how it's set up, what my thought process was, and then we'll look at some actual testing and performance to see how it turns out. This is where the tinker portion of the channel name comes from. I have got all sorts of different bits and bobs. I have got my DWV sewer pipe, I have got blast gates, I have got flexi hosing, I have got couplers, and they don't all quite fit together. My goal is to get these blast gates to be able to connect to these Ys just like this, but they're really sloppy. So I am taking measurements of everything and I'm gonna try to do some modeling, I'm not very good at that, and see if I can 3D print some parts to adapt that to that with a nice tight fit. I wanna show how I created this component in CAD. And I wanna preface by saying, I don't know how to use CAD. I log into Fusion 360, I get frustrated because it doesn't make any sense, and I tell myself at some point in the future, I'm going to sit down and I'm going to learn how this application works, and then that some point never comes. I can, however, use Tinkercad. Tinkercad, I could get my head around, it makes intuitive sense to me, and it is made up of primitives. So as you can see on the right hand side of the screen, you've got cubes, you've got cylinders, you've got cones, you've got spheres. So if you can conceptually break your object into those shapes, you can actually do a lot of things with Tinkercad. There are absolutely limitations. You're not going to necessarily make the most complex shapes, and you're not going to employ the best CAD practices. I don't think that you can chamfer edges. I don't think that you can put fillets on things. Like, there are limitations to what you can do with Tinkercad, but for quick and dirty and not sitting down and learning CAD, this is eminently accessible. I put this part together in less than 30 minutes, and I'm not going to walk through how I put it together and show putting it together, but I thought I would show the part and break it apart so that you can see the thought process that went into putting it together. The key thing is going to be having your calipers, so you know what your measurements are, and then translating it into those objects inside your own head. So here we can see our part, and if I select it and break it into its constituent components, we can see it's really made up of essentially 5 parts. I have a cylinder at the bottom that is sized to go into that PVC gate. I have a ring that keeps it from sliding all the way into that PVC, And then I have this blue cylinder at the top that is what the blast gate slides into. I have a cylinder at the bottom that is set as a hole that goes through to this ring. And then the cylinder at the top is actually a primitive that is a tapered cylinder so that it will fit that blast gate perfectly. And it's sized so that the diameter at the bottom is narrower than the diameter at the top, and that blast gate slides right in. That's a little extra that I did. And if I didn't try and do that and I just made it 2 cylinders, one size to the PVC pipe and one size to the blast gate, I probably would have been done in 15 minutes. But instead, because I had to get fancy with the tapering, it took me 25, maybe 30 minutes. And that's all it is. It's just 3 stacked cylinders with the hole punched through. And then you select everything, you merge it together, and now I have one object that is ready for export, and I can take into my 3D printing slicer. I can slice it and I can send it off to print. Now, I did do some test prints to make sure that my parts were going to fit before I committed to the whole thing, because on my printer, it's about 3 hours to print one of these, and I didn't want to waste 3 hours and the filament to find out I had a measurement wrong. So I printed a little bit of this bottom ring, a little bit of this top ring, and said, hey, that fits, now I can commit to printing them. So that is sort of the approach that I take to using the 3D printer in the workshop when I can't find STLs that are already built for the thing that I'm looking to print, which a lot of times other people have had the exact same challenge and they have solved it far better than using Tinkercad. I'll put a link to the STL in the description below in case anybody else is trying to solve this exact same challenge in their shop and doesn't want to do the modeling. But again, with Tinkercad, it really makes it super easy to put together primitive pieces like this, and you don't have to know full-blown CAD applications. All right, 3 hours and 4 minutes later, and we have our part. This fits in there. It is just a hair loose, but with a little bit of tape on the outside, it's going to be perfect. And then this fits in there, and that is an absolutely perfect fit. Put a little bit of tape on here. There will be no air leaking. That is an awesome power. As far as I'm aware, there isn't a part that I could find to adapt this to this. I have seen different tips and tricks, such as using 5-inch blast gates and a piece of pipe here, but I don't have 5-inch blast gates, and these are significantly cheaper. Now, the whole point of this is that this will be the last connection before I go to flexi tubing. So I don't care that this is very slightly smaller. Everything else is going to be the full width all the way through. 3 hours of printing, and I've got one of those. I have another one printing on my other printer here in the shop. That one's going to take slightly longer. It's an older, slower printer. I'm going to go back. I can fit 3 of these on a print bed. It's going to take about 10 hours. This one, the 3 that I'll print, plus the one that's printing in here, and I will have enough of these adapters that I'm all good. And if you're curious, this is PETG, and it is, I mean, I am really reefing on that, and it is just not deflecting. So plenty strong enough for this application. Just kind of giving a sort of wide overview shot of how everything is laid out. I have got the dust collector over in this corner. I come up and I split off. I've got a run that comes along here and drops down over here where the drill press is. I have a router there that I don't know if it's going to continue to live there. I might sell that and get something else. And I have a sander, so I still need to figure out dust collection. I've got that 20-foot Rockler extendable dust right hose, which is too long for there. I need to figure that out. It does actually do a pretty good job at the drill press, so I'll show some footage of that. And then I come up and over and then down here to my cluster with the bandsaw and the combo joiner planer, and I've got 2 45Ys here, so I go to each tool. I have blast gates on each of those. And then I continue all the way to the front of the shop and I go down where I have 2 additional 45s to connect to the table saw and the overhead arm on that side, or the table saw and the router that's in the end of the table saw wing on this side. Here's how I've got really both of my tool clusters set up. They go all the way to the floor with the PVC. I have a cap on the floor, and then this is just friction fit. I can absolutely slide it out of the way, but otherwise it sits here, it pushes everything up against the ceiling, and then I've got my two Ys to connect the tools with blast gates on each of those. And they are just the inexpensive PowerTech blast gates, but they seem to be working just fine. I've got my 3D printed coupler here, and right now I'm just using some white duct tape. I'm not sure how well this is gonna work long term. I may switch this to an actual true like aluminum duct tape at some point, but in doing some testing, I don't seem to have a ton of excessive air leaks, and I'm pulling pretty good numbers at these blast gates. So I'll show the anemometer and we can actually see some real world readings. Just showing a quick anemometer reading. Get the dust collector turned on here. And I'm at 5,156 feet per minute, and that is through this Rockler Quick Connect, which I put on the joiner planer because I have to disconnect it to move it. I actually get slightly higher readings if I just come off of this 4-inch connector, but that's not bad. That is far higher than I was getting before with the 20 some odd feet of that Rockler flexible ducting running all the way back to the dust collector. This is sort of the area that I don't really have figured out yet, and I'm trying to minimize using this as a walking path, so it's a bit of spaghetti here. This PVC tube I have left long. I probably need to cut this down a little bit, but this goes all the way to the cabinet of this table saw here, and then it is pretty much permanently connected to this bottom blast gate here. And then I have used these generic dust right fittings. These I got on Amazon. They are not the Rockler brand. And with just a little bit of tape here, they friction fit over these blast gates. So I have this one which connects to this overarm duct, and I've got this on this blast gate. I have this one which goes to my other cabinet saw, and then I also need to get some more of this flexible ducting so I can go all the way along the bottom and connect to my router box. I don't have that currently. So these are going to have to be a sort of plug and play as I use them. I am intending to keep the overhead arm collector and this table saw connected all the time because that's the one I use the most. The other table saw is set up as a dedicated dado saw, and I don't make as many dado cuts. And then the router, I mean, I do router projects on as I need them. And so that's still something I need to address by getting a little bit more of this flexible ducting. And I may do the same thing I did here with some of, I have a little bit of excess sewer pipe left, and I may try and extend that as far as possible just to minimize the friction losses in the flexible ducting because they are pretty significant. So this makes this a little treacherous to come through, but I don't have a better solution right now, and I'll just minimize people coming through this part of the shop. And then showing the furthest blast gates. So this is going up 10 feet and then going all the way across the ceiling to the back of the shop, over 25 feet of ducting. So this is no flexible tubing, and we will do the test. So according to this, 7931 before it goes into any ducting. And that is my furthest run. So pretty substantially higher than what I was getting running through that 21 feet of the Rockler flexible ducting. To show some real world testing, I've got this strop right here, which is connected to the 21-foot flexible Rockler dust right hose. And if I turn the system on, we'll take a reading with the anemometer. And of course I've maxed it right out. I don't know if you can even hear me. Let's not set it to max. There we go. All right. So 6,810 feet per minute. And as you could hear, it did spin, and I was getting a high reading. So I'm getting pretty good suction, even with it coming up, over, and down. So there is 10, another 4 is 14, probably another 5 is 20, and then another 5 or 6. So I've got over 25 feet of piping, and it splits off and goes to the other side. But if I measure it right from the blast port, you might be able to hear the difference, assuming that you can hear on the audio of what it sounds like. So obviously that is high, and it pegs this little anemometer. I think it goes to maybe 9,999 feet per minute, but yeah, it's significantly faster moving air velocity here. This ducting really has a ton of friction in it. And then the last thing that I want to show, because I'm so tickled about it, is just the ability to collect chips at the drill press. So let me go get a piece of scrap wood, and we'll make some chips and we'll collect them even through the 20 foot of Rockler dust flexible ducting. I'm particularly excited about having dust collection at the drill press. I'm going to get some of that rigid line that will hold its place so I can come off of my blast gate and leave that set up more or less permanently here so that it's set up to collect chips. For now, I'll just make a test hole here. I'm using a 1 3/8 inch Forstner, and when I use Forstner bits here, they throw chips everywhere, and then I spend a ton of time sweeping back behind everything and vacuuming them up with the shop vac. So if this can eliminate the majority of that, I'm super stoked. So for this test, I'm just gonna hold this ducting because I don't have the right stuff yet, but you'll get the idea. It does a fantastic job of picking up chips here. It's not perfect, but it is so much better than just letting this messy thing fling chips everywhere. Apparently I have a dull Forstner bit. Yeah, that Forstner bit could be a little bit more sharp, and this chuck could be a little bit tighter, but other than this chip, I think I got all of the chips that came out of this hole. So super excited about that. We'll do some tests at the table saw, but first I thought I'd get some readings with the anemometer. So I have both the overarm port open. I also have the port to the cabinet open. So we'll start with the reading for the overarm. And I'm taking the reading here at the bottom of this. Obviously, if I take the reading right off of this port, it's going to be substantially higher. I can feel a good bit of air moving there. And if I put this under here, I am, let's set it to the max. Yep, I'm at about 570 feet per minute. So I'll have to look at my previous video and see what that was, but that is both the overarm port and the cabinet open from the riser there. And if I grab a screwdriver, we'll take a reading on this flexible hose. So taking the flexible hose as far out as it can, I am at 3250, 3260 before it goes into this box. So that is substantially higher, and that's actually with 2 ports open on the tool. And we'll also get a reading from here. And again, I have that big shroud So this reading is going to be, well, let me move this out of the way so it's not competing. So I don't know how good of a reading this is going to be, but it is reading at 196 feet per minute. So not great, but I can absolutely feel air moving if I put my hand down in the shroud. And don't worry, the table saw is turned off. So the next thing to do is to move everything in place, get the table saw turned on, and make a test cut. I just have a scrap piece of OSB here with some runners on it that I had made a jig with. So we're going to just make a test cut, both with the overarm collector and the cabinet going. So we'll see how much dust gets kicked out or what kind of a job it does collecting the dust. So we'll turn the dust collector on and then we'll make our cut. All right, and as I look around, there's a little bit of dust that got kicked out. Otherwise, I'd say it did a pretty reasonable job of collecting the dust. So now we'll try it without the overhead running and see if it does a worse job or if more air going to the cabinet does a better job of pulling those chips down. All right, so now we're just making the cut with the cabinet having dust collection. The overhead arm, the blast gate is closed and it's not going to be doing any dust collection. So we'll get the system going and make our test cut. Yeah, I really didn't see a ton of dust get thrown forward. Maybe it'll show on the video. Sometimes you can see it on the video when you can't see it in real life. I would say that did a better job than when I was running the flexible ducting over and connecting it directly to the cabinet, which is actually kind of impressive because it is running through, well, it's not 8 complete sticks, but let's call it 7 anyway, 7 10-foot sections of PVC. That is the whole system complete with all of the splices and cuts. Plenty of opportunity for there to be air leaks. So I'm reasonably impressed. I suppose the next thing to do will be some tests on the joiner planer and see how that does collecting the chips. I'm going to use the same piece of red oak that is just about 1 inch thick and 6 inches wide that I used for testing when I first got this Harbor Freight dust collector and cyclone separator. So this jointer does have a helical head, so it should make a lot of chips, and historically I would have difficulty doing a 6-inch wide board and collecting all the chips. I would get some that would throw out the front, throw out the back. So let's turn it on and see what kind of collection that we get. So I've got my blast gate open. Let's make the cut. There's a few chips thrown out the back, but not too bad, and really none that I see that were thrown on the floor. So there are a few chips thrown out the back, but not too bad. It didn't collect 100%. I'd say it collected 75, 80%, and I don't really see any chips that got thrown completely off and onto the floor. Maybe the video will show otherwise, but significantly better than what it used to be. I don't remember if it was better than when I was just directly connected with the flex hose, but way better than when I had the old dust collector. So let's flip this into planer mode and let's take a pass off the board as a planer. And wouldn't you friggin' know it, for whatever reason, the rollers that control feeding the board in planer mode are not engaging. And the lever, which you should be seeing right there, feels a little spongy. So, never had a problem with this machine before. But of course, as soon as I want to shoot some video, we have to break out the tools and take it apart and figure out what the heck is going on. And would you look at that? Hopefully a super easy fix, but the belt has jumped off of this pulley, and it looks like it just rides on that, and then just needs to go around this pulley. Hopefully that doesn't mean that I'm gonna need a new belt soon. There we go. And as I turn that by hand, all right, that is turning the helical head, and I can see it is turning the rollers. So, little detour. If you ever wanted to see inside of one of these Canadian Woodworking Scorpion joiner planers, there you go. All right, back to the regularly scheduled dust collection test in a minute, as soon as I get this put back on. Kind of nice. This is a really heavy plate. Makes you feel like you get something for your money. They put extra gravity in that plate. And, not to toot my own horn, but I grabbed the right hex key out of the rack. First time. It's a special power. Estimating the hex key that I need. So, you know, if you ever need to know what hex key, send me a picture and I can tell you. First time, every time. Of all the superpowers to get. That's a terrible superpower. Anyway. Back to the tests. As I was saying before having to stop to fix the belt, this board is about 15/16 of an inch thick. We're gonna take a light little pass to see how many chips get caught and how many chips get kicked out. My platen in here should be clean, so let's see what the dust collector can do. Looks like we need to take just a little bit more off. So as I look down, I see a very little bit of chips on the platen of the planer. But again, not very much. It really did a good job of sucking them up. And I'm not sure if the camera was able to catch anything going through that clear plastic hose. I didn't even think to look at it. So hopefully the camera caught something interesting. I wanted to go over all of the parts that I purchased and my cost to put this system in, because I know that that question is going to come up. So I have done some ciphering and I'm going to give a breakdown of everything I purchased, what I paid for it, and what it would cost to put this entire system in. So I got the dust collector and the cyclone separator at Harbor Freight. I paid $450 for the dust collector. I paid $300 for the cyclone separator. I didn't get them on sale. I didn't have a coupon. That's $750. I bought a 5-foot length of 6-inch flexible hose, and I bought 30 feet of 4-inch flexible hose. I need a little bit more of the 4-inch. But I paid $26.50 for the 6-inch hose. I paid $78 for the 4-inch hose. That's another $104.50. I paid $64 for the remote control, and it came with 2 remotes, which is nice. And it is a 220 volt remote control because I rewired my system to run on 220. I bought a 6-pack of PowerTech 4-inch blast gates. I ended up using 5. I paid $29 for those. And I bought 10 of the PowerTech hangers. I paid $20.50 for those. I sort of ran the calculation of my time to print and cost to print against 20 bucks, and 20 bucks won out. They were delivered the next day, so I didn't have to wait for them. It was gonna take an hour and a half, almost 2 hours to print 2. So yeah, that was easy math. So that is another $113.50. So for the dust collector, the cyclone separator, the ducting, and then those components, $968. And then for the PVC plumbing or ducting, I went with 4-inch drain and sewer PVC. I originally said I was going to use 6-inch. I think I would have liked to have used 6-inch, other than it would have taken up a lot more space because 6-inch PVC is significantly larger. However, it was going to be significantly more expensive. When I first sat down and was figuring the components that I thought I would need, and I needed far more than I thought I needed, I was going to be over $600 for the 6-inch PVC, and I was going to be in that $150 to $200 range for 4-inch PVC. I ended up spending a bit more than that for 4-inch. It would have been quite a bit more if I would have gone with 6-inch because I needed more components than I thought I needed, and the 6-inch fittings are substantially more expensive. For example, the 4-inch Ys that were $7.50, the 6-inch version of those Ys was almost $30 a piece, and I used 7 of them, so that is a big jump in price. So for the PVC, I used 8 sticks of 10-foot pipe. They were $12.25 a piece. Because I bought 8, I got a contractor discount rate, so that was $98. I ended up using 7 of the 4-inch by 4-inch Ys. They were $7.50 a piece or $52.50. I used 11 of the 45-degree elbows. They were $5 a piece or $55. I used 3 caps. They were $3 a piece or $9. And I used 2 couplers to connect PVC to PVC where I didn't have a bell end. They were about $3 a piece or $6. So all in, that was another $220.50 in PVC parts, bringing the grand total for everything to $1,088.50. Call it $1,200, because this doesn't include tax. What I didn't include were some of the things that I already had, some screws and fasteners. I didn't include 3D printed parts because I already have a 3D printer. Maybe I used a spool and a half. If you didn't have a 3D printer and you budgeted another $50 to have somebody make the 3D printed parts, I think that that would be well within a reasonable range to pay for a service to make the 3D printed parts. But I'm not counting those in my total. So $1,200 all in to put this system in. I don't think that's too bad. I just would have been getting my foot into the price range of 2 horsepower separator systems from some of the bigger players at that $1,200 price range. And then I still would have had to have put, hundreds of dollars in for blast gates, for the flexible ducting that I needed, and for the plumbing. So I would have had those fixed costs regardless of what system I put in place. So I'm pretty pleased with what I was able to accomplish for the $1,200. I had a comment asking, why I didn't go with one of the bigger systems. And don't get me wrong, I would love to be able to put in a Harvey gyro or something from Oneida, or heck, even one of the higher end Laguna, Grizzly, or Jet systems. But my big expense was building this shop. And so that means that I have to be budget conscious. And my budget for tools was largely taken up by a building to put the tools in. So Completely reasonable question, but I didn't have the money to spend and couldn't justify spending that kind of money as a hobbyist. So I wanted something better than what I had, and I think for the money, I was able to get it. I know I started this series by asking the question, was that dust collector any good? Was the cyclone separator any good? And I think at this point I can say, yeah, it's pretty good. I think it's great for a small shop. And while my shop is pretty big, I have the dust collector and the tools that it's connected to really in the space of about a 1-car garage. So it's 25 feet from the front of the shop to the back of the shop, but I'm only coming over about 10 feet. So 25 by 10, that's a big 1-car garage, but it's still a 1-car garage. And I've got it all in. It's feeding 2 saws. It's feeding the overarm dust collector. I've got a drop for the drill press sander router table if I end up using that router table. I've got the joiner planer. I've got the bandsaw. I've got all my tools connected. And it's doing a really good job for the money. Like I said, I could have spent about $1,200 just getting into a decent 2-stage separator dust collector system, maybe from a Jet or a Laguna, maybe even a Grizzly, but I would have still had to have put another few $100s in, so I would have been probably north of, say, $1,500, $1,700 by the time it was all said and done. Maybe that would have been the better route to go. I don't know. This is the route I ended up going with. And I think I can say to anybody else who's kind of curious and wants to look at something without spending a ton of money, this is a pretty decent little system. So hopefully these videos have been helpful. Hopefully you've enjoyed them. Hopefully you've learned something. If you'd like to follow along with my future journeys in the workshop, I would invite you to subscribe. And if not, thanks so much for watching.